Hi everyone, this is Yashasvi. I am a third year college student and I've recently cracked Google internship. I did a step internship in this summer, which is 2025, but I got a PPI and I'll be returning again in 2026 as a SWE intern at Google.
So guys, with the name of God Ram Ram, we are going to solve the maths and tree problem, which was asked in Codeforces Round 1107 Div 3E. Okay, so this is the problem, and before solving it, you need to know some basic concepts, which I'm telling you in advance. The first thing you should know is what is a tree. Okay, and the second thing which you need to know is bottom up DFSDP. What is this thing? If you don't know, go to our tree course and do it. The link to the tree course is available here. Okay, not here, here. So you just have to open this course link, go to our general tree course. You will find it here. Session 1, Session 2, Session 3, Session 4, Session 5. And just complete all the videos of the general tree course. Just complete all of them. That's it. And you will understand what I'm trying to say. Okay. So now we have to start the procedure. They are saying that find the number of valid unordered triplets. It means you don't need to bother about the order. Find unordered triplets UVW such that PUV multiplied by PVW multiplied by PWU is a perfect square. Yesterday also we were discussing something about the perfect square. Okay, so like there can be a tree like this. Okay, let's say this is the node U, this is the node V, and this is the node W. Okay, and let's say the values are 2, 3, 4, 5, 6, 8, 8. And let's say okay, what can be the values of the numbers actually? 10 raised to 6. Okay, fine. And let's say V is 9. So we have to figure out what is the, if this is the tree, this is node U, this is node V, this is node W. So how will you calculate P of U comma V multiplied by P of V comma W multiplied by P of U comma W? This thing should be a perfect square. So I will open the Google chat. You guys have to tell me the three values. Okay. What is P of U to V? Very simple. Just chill out. Just chill out. U to V means if you go from U to V, what is the product of the numbers? 9 into 3, 27. 27 into 2, 54, right? Yes, sir. Then what is P of V to W? 5, 6 are 30. 30 into 4, 120. 120 into 9. I don't remember 12 nines are what. Okay. 12 tens are 120. So 120 minus 9, something like that. Oh, sorry, 120 minus 12. So 120 into 9, 5 6 अच्छा नीचे का हाँ सही है 5 6 30 34 120 120 into 9 ठीक है. So it should be 1180 I think. Okay, this will be 1180 if I am correct. छोड़ो इसको बाद में लिखेंगे. P of U to W multiplication of all these values like 2 into 3 into 9 into 4 into 5 into 6. So just to check whether this triplet is valid or not, it is taking so much time. P of any two numbers is nothing but go from that node to the other node and calculate the multiplication of all the values. And as you are dealing with a tree, only a single path is possible from any node U to any node V. Okay. So I will open the Google chat. You guys have to tell me what is P of V comma W. If you multiply 9, 4, 5, 6, what do you get as the answer? Tell me that thing in the Google chat. P of V comma W. So guys, Google chat is open. Tell me what is P of V comma W. 1080. Not 1180, it is 1080. Okay. I was also doing a similar type of mistake. So this is 54 multiplied by 1080 multiplied by, who can tell me the value of P of U comma W? Basically all these values multiplied by 2 and 3, 6 multiplied by 1080. 6480. Guys, tell me what is the value of P of U to W? Use the calculators you have and tell me P of U to W. in the Google chat. 6480. Okay. Now guys, multiply these three values and tell me, is this a perfect square or not? What is the perfect square? Any number of any k greater than equal to 1, then k square is a perfect square. So is the multiplication of these three numbers leading to a perfect square? अरे भाई कितना बड़ा काम है. 54 into 1080 into 6480. Yes, it does lead to a perfect square, but tell me what is the final output? What is the final output? Huh? If you multiply all these numbers, चलो मैं खुद ही multiply कर लेता हूँ. 1080 into 6480 multiplied by 54. इसका स्क्वायर रूट. अरे रे. This is the output. Is this a perfect square? Yes, guys. 19,440 multiplied 2 times gives us this answer, which is the output of this. So it is a perfect square. Clear? Okay, good. Good going. So we have now understood the question. Now, how to solve it? That is a totally a different ball game. How to solve it is a different ball game. So we have to solve the problem. How do we solve the problem? By having some fun. Most probably by having some nice amount of fun. Let's see if someone has sent the email ID. We'll just will send you mail by tomorrow 2 p.m. Okay. Now guys, we have to do is we have to do some analysis. Okay. So the analysis will be pretty simple. Uh, Always in these types of tree problems, now always try to think, how will the path actually look like? How will the path actually look like? No matter what is the tree, how will the path actually look like? You can try to decrease the complexity of the question. They are telling you find the valid triplets u comma v comma w. To make sure you count distinct triplets, try to center all of them around v. Try to fix the node v and then try to find the valid u and w's. Okay. So try to fix the node v. What you will do is try to fix the node v. Okay. To make the problem simpler, to make the solution simpler, to find valid triplets u comma v comma w, fix each node as v and try to find valid u and w for the given v. So guys, we will travel each node and we will assume that our current node is v. Okay, so I will show you some example. We will assume our tree is rooted at node number 1. Node number 1 is at the top. Okay, so tree is like this, like this, like this, like this, like this, like this. Let's say 2, 3, 4, 5, 6, 7, 8, 9. Okay, okay sir. So one thing is very interesting. Let's say I want to find all the valid triplets UVW such that V is equal to 3. So first I will count all the triplets such that the third node is V. Then I will count all the triplets such that V is equal to 4. Then I will count all the triplets such that V equal to 2, V equal to 1. Like this, I will iterate all possible V's and I will be able to calculate. All the valid triplets UVW such that V was the middle value and that middle value was distinct. And we will make sure that we don't do any kind of overcounting. Okay. So guys, there can only be two types of paths. Okay, there can only be two types of paths and you have to be very careful while counting them or else lots of problems can occur. See, in this problem, the issue is not the question. The issue is that very easily the person can by mistakenly do overcounting and get in a problem. Okay. So I don't want that to happen. So in this session will be divided in two parts. Next session of this problem will be tomorrow. The first session is today. Why? Because there are two types of paths. Two types of valid paths are possible. Two types of valid paths are possible. First is type 1, which is simple paths. Simple paths. In simple paths, what happens is that you go from U to V and you just go from V to W. Type 2 paths are T-shaped paths. So this much you have to analyze yourself, okay? How to count the type 1 parts? So in today's session, we will focus on how to count the type 1 paths. Once you are done counting this, in tomorrow's session, we will focus on how to count type 2 paths. Add both of them and you will get the answer. So what is the type 1 path? Take any big tree. Take any big tree. It can look like whatever you want it to look like, does not really matter. This is U, this is V, this is W. So see this is called as a type 1 path. Why? Because you can go from U to V. V is our middle node. And from V, you can just go to W and have some fun. Okay. So you can go from U to V and then you can go from V to W. So the full path is just a single line. We call them as type 1 paths. Okay. So these are called as the type 1 paths and you should never forget about them. Clear? I will show you some more trees, okay, to clear up the type 1 paths for you. So let's say, let me change the UVW and let me write some U. This is U. Let's say this is V. This is W. Tell me if U to V and V to W this time, is this a type 1 path or a type 2 path? I will open the Google chat. You guys have to use your brain. You guys have to write in the Google chat whether U to V and V to W is a type 1 path or a type 2 path. So guys, please tell me. Type 1 means it is totally simple. It is a type 1 path. You go from U to V. See, everything is simple. V to W. जब तक चीजें सिंपल है उसको टाइप 1 पाथ बोलते हैं. समझे बात को? क्लियर ना? ओके, सबने टाइप 1 ही लिखा है. So it confirms my belief that your IQ is high. Thank you. मैं तुमको पढ़ाते पढ़ाते मेटा थॉट्स में जा रहा हूँ. मैं कुछ और सोच रहा हूँ, इसलिए दिक्कत हो रही है. मैं बताऊँ मैं क्या सोच रहा हूँ? मैं पढ़ा रहा तुमको ये हूँ और मैं फ्यूचर का सोच रहा हूँ कि इनको टाइप 2 का कैसे पढ़ाऊंगा. This is called as overthinking. Let's stop the overthinking. Now I am in the present moment. Only focus on type 1. टाइप 2 का मेरे बच्चे बहुत स्मार्ट है, वो शायद अपने आप समझ जाएंगे जब मैं उनको समझाऊंगा. तो टाइप 2 भाड़ में जाए. टाइप 1, U to V and V to W is a singular path, so everything feels good. Okay, so you understand these things. And guys, while counting these type 1 paths, I don't want any kind of repetition. So how can you assure that? For example, if this was the V, okay, U V W or whatever, how to make sure that the same path does not get counted again? Array, it will not get counted again. Okay, it will not get counted again. The UVW can never get counted again. If this node was V, then these two could never be U and W. Okay, if these were U and W, then it would not be a singular path at all. And we are only focused upon calculating the singular paths for now. Got the point, guys? Got the point? So focusing on the type 1 paths. Now I will show you the type 2 paths also, which we will discuss later. Okay. Like, we are not talking much about the type 2 paths now. We are only focused on counting the type 1 paths. So let's try to increase our focus on the type 1 paths. So how does the type 2 path look like? I will show you today. UVW. Now see what happens. In type 2 path, what happens is you go from U to V. Then guys, double time you have to visit this line from V to W. Can you see what just happened? This was U. Like this, you went to V and then there is some common line which you have to visit and go to W. So this is a T-shaped path. Whenever the path is something like this, U, V, W. Means if UVW are not coming on a single line, okay, like you can see here, 2, 5 and 8, 2, 5, 8 are not coming on a single line. Guys, can anyone tell me that why is UVW a type 2 path? In this tree, U to V is like this, then V to W is like this. So this is not a type 1 path. Whenever there is a triplet U comma V comma W, such that you cannot go from, such that you cannot travel a single path, such that U comma V comma W all three appear in a single line. If that thing is not happening, then guys it is a type 2 path. Type 2 path में हमेशा T shape आएगा. Okay, clear? So great going. So guys, everyone write in the Google chat now. See, this session, only those people will be able to remain for long who have higher level of intelligence. Okay, so I don't worry. I'm actually very happy because you guys are paying attention. Now listen, everyone write in the Google chat that type 2 paths are T-shaped. So write in the Google chat type 2 equal to T-shaped. That gives me the confirmation that you have understood that the type 2 paths are always T-shaped and the type 1 paths are always single line. So just write that in the Google chat and never forget. Okay, type 2 T-shaped. Can anyone write something about type 1 path? Type 1 equal to single line. बेसिकली टाइप 1 वाले ऐसे हैं कि बस सीधा भी ट्रेवल करोगे तो तीनों नोड आ जाएगा उस पाथ में. Singular line is type 1. I hope it is going deep in your brain. Okay, now similar types of questions are there in our course. Okay, we have done even a harder version of this problem few days back. Anyways, so how do we count the type 1 paths? Very easy indeed. Not a big deal. Kumar ke students can do it easily, even while sleeping. Okay, so let's say my current node is V. So guys, this is a very big tree. Huh? The root of the node is 1. Very big tree I have. I want to count the type 1 paths. I will fix each node as my V node and then I will try to count the type 2 paths. Okay, let's say this is my node V. Guys, this is my node V. This is my node V. So let's try to, this is my node V. How many valid paths will be possible? Before discussing that, let's see how does it generally look like. Type 1 paths look like this, right? This is U. Then you reach V somehow, assuming V is in the middle, bro. Then you reach W. Let's call this node value as A1. This node value as A2. This node value as A3. This node value as A4. So if you try to write the multiplication, what is going to happen? P of U comma V multiplied by P of V comma W multiplied by P of U comma W. What it will be? AU into A1 into A2 into V. Multiplication of these four things is P of U comma V multiplied by PV, sorry, it is not V, it is A of V. So AV into A3 into A4 into AW multiplied by this whole thing again. AU into A1 into A2 into AV into A3 into A4 into AW. Guys, can you see some pattern in this whole product? React with emojis. All the numbers are coming 2 times except AV. Guys, can you see that all the numbers are coming 2 times in that total product? If I rewrite this product, how will it look like? The final product is AU square multiplied by A1 square multiplied by A2 square multiplied by A3 square multiplied by A4 square multiplied by AV square. This full thing multiplied by A of V, because it is A of V ka whole cube na. So A of V square into A of V is A of V ka whole cube. I am separating it out. A of U coming 2 times, A1 coming 2 times, A2 coming 3 times, A3 coming A1 coming 2 time, A2 coming 2 time, A3 coming 2 time, A4 coming 2 time, AW coming 2 time, AV coming 3 time. 1, 2, 3. So every square this. Now guys, square into square into square into square is a perfect square. So perfect square needs to be multiplied with a perfect square, then only the product will be perfect square. So when is the product perfect square? If I give you UVW in a single path, when is it a perfect square? It can only be a perfect square if and only if value of middle node is a perfect square. देखो आपको कितना चोमू बनाया गया था क्वेश्चन में इतना बड़ा एक्सप्रेशन लिखा था that this thing should be a perfect square. But guys, what is the reality? UVW triplet is a perfect square triplet if the node with value V is a perfect square. Bas khatam. But they wanted you to figure this out yourself. So guys, what does this mean? Is a good triplet if A of V is a perfect square. Guys, you can just write a simple check function and you can check whether this number is a perfect square or not. If it is not a perfect square, no need to count any values. Guys, write brilliant in the Google chat if you have understood what is that trick that you only need to check the V node value और बाकी कुछ check करने की जरूरत ही नहीं है. Write brilliant and give me the confirmation कि तुमको समझ आ गया. अच्छा, तो ये सब जो हमने बातें की इसका क्या मतलब हुआ? The meaning is that the triplet is good if the middle value is a perfect square. If the middle value is not a perfect square, no need to count the triplets. That's it. Clear? Okay. Good. All the people in the meeting, make sure you like this LinkedIn post. Okay? Don't forget to do that. It is in the Google chat. Now, now guys, I am totally changing the question. Let's say this is my value. This is my node V. And let's say A of V is 9. Guys, A of V is 9. It means you are allowed to calculate the triplets. अगर मुझे पता है कि नोड V का वैल्यू 9 है तो ये तो अच्छी बात हुई ना, ये परफेक्ट स्क्वायर है. तो अभी कोई अब सारे U, W हम ढूंढ सकते हैं क्योंकि V वैल्यू परफेक्ट स्क्वायर है तो मतलब घूम फिर के टोटल प्रोडक्ट परफेक्ट स्क्वायर ही आएगा. इफ आई ट्राई टू रिपीट इन इंग्लिश, if A of V is a perfect square, then try to calculate how many valid triplets UVW exist for the current node V. So guys, if this is the node V, how will its diagram look like if I try to separate it out? इसका डायग्राम बनाना चाहता हूं मैं. चलो स्केचपैड पे चलते हैं. Then we will write the pseudocode also for this. Don't worry, guys. अगर ये मेरा नोड V है तो इसका डायग्राम कैसा दिखेगा रियल में? ये V है, ठीक है. कितने ब्रांचेस निकल रहे हैं? 1 2 3 4. देयर आर 4 ब्रांचेस कमिंग आउट. ब्रांच 1, ब्रांच 2, ब्रांच 3, ब्रांच 4. ओके, let's call this branch as this subtree. Okay, branch 1, and this is another subtree, and this is another subtree, and this is another subtree. So guys, the problem is immediately solved. How many nodes are there in this branch? 3 nodes are there. Array, so you can take any node from this branch and any node from this branch and they will be valid U, W because they would be making a simple path. Can you not see that? Can you not see that? मेरे कहने का मतलब है कि ये V से जो एक ब्रांच निकल रही है उसको देखो भाई, और ये V से जो दूसरी ब्रांच निकल रही है देखो भाई. इस ब्रांच में कितने नोड है? 3. इस ब्रांच में कितने नोड है? 3. तो 3 मल्टीप्लाइड बाय 3, 9 triplets are possible where V is the middle guy. How? This can be U, this node can be W. Then W has three options and U also has these 3 options. So guys, you all need to know is that how many nodes are there in the subtree of each branch. So in this branch, how many nodes are there? 3. In this branch, how many nodes are there? 3. Okay, 1 2 3. Okay, there are 5 branches. Sorry. There's one more branch. Ruthless. In this branch, there is 1 node. Then there is one more branch. 3 3 1 1. In this branch also 1 node. Can you see how nice the problem is? And in this branch, the rest of the tree, bro, rest of the tree has how many nodes? 1 2 3 4 5 6 7 8 9 10 11. 11 nodes. So guys, now you can make pairs of. What you can do is that you at one time you can pick any 2 branches and you can find the number of ways. So guys, if I try to make an array of the branches, what it will look like? 11 comma 1 comma 1 comma 3 comma 3. This is how the array looks like. If my current node is V and I try to make the array of the size of the size of the branches is 11 comma 1 comma 1 comma 3 comma 3. Everyone react with emojis if all the people in the meeting agree with me that for the node V, where A of V is a perfect square, the size of the branches is looking like this: 11 1 1 3 3. Do you all agree with me? What will be the final answer? Final answer is nothing but product. All pairs of product. You can take a node from here, the branch with size 11, and you can take a node from here. So one possibility is 11 multiplied by 1. Take any node from 11 and call it as u, and take any node from this one and call it as w. So u v w, like this. So 11 into 1 plus 11 into another one plus 11 into 3 plus 11 into 3 plus 1 into 1 plus 1 into 3 plus 1 into 3 plus 1 into 3 plus 1 into 3 plus 3 into 3. Guys, answer is nothing but what? Summation of ai into aj. Sum of product of all pairs of the array. For each node v, if a of v is a perfect square, calculate the special array. Calculate the special array b. Let's calculate the special array b. So answer will be what? Sum of product of all pairs of numbers in the array b. Do you even understand how brilliant this problem is? We have not even started talking about the type 2 paths. Just type 1 paths have opened up our brain. I will go to each node in a tree. I will check if this guy is a perfect square. Then I have to calculate the special array b. Once you have the array b, you can calculate the sum of product of all pairs in the array b, right? This I leave it up to you. मुझे मत पूछना कि सर एक एरे में सम ऑफ प्रोडक्ट ऑफ ऑल पेयर्स कैसे निकालते, वो मैं नहीं बताऊंगा. उतना तुम्हारी अभी उम्र हो चुकी है, 20 साल के ऊपर हो चुके हो, तो वो काम तुम खुद से कर लो, ठीक है? नहीं आता तो हैशिंग प्रीफिक्स सफिक्स कोर्स पढ़ो. यू विल अंडरस्टैंड हाउ टू कैलकुलेट द सम ऑफ प्रोडक्ट ऑफ ऑल पेयर्स इन O of n टाइम, नॉट O of n स्क्वायर. Now the thing is, guys, how will we calculate the array b? How will you calculate the size of all the branches? So guys, if I open the Google chat, can you tell me for any node v, how can you immediately know the size of all the branches? Write your logic in the Google chat. तुम कोई भी नोड वी के लिए कैसे पता लगाओगे कि इसके सारे के सारे ब्रांच का साइज क्या है? अरे चिल्ड्रन सब ट्रीज, you need to pre-calculate the size of all the child subtrees. You got the point? And for this, we have to do bottom-up DFS DP, from bottom to up. If you don't know this concept, then go and do the prerequisite course where I have taught you this concept. Okay? You go to the tree course and watch these 5 videos. You will understand what I'm trying to say by saying bottom-up DFS DP and the size of children subtrees. Okay? You guys understand now? Bottom-up DFS DP. Yeah. Post order traversal looks nice when you are calling it about binary tree, actually, not general tree generally, but still okay. So ये bottom up DFS DP क्या होता है? इतने सारे बच्चों ने, first of all thank you. ये bottom up DFS DP, I have invented this term on my own and my students are writing my same term. Love you all. Now listen. So this is a child thing. It is very easy. This is node 1, node 2, node 3, node 4, node 5, node 6, node 7. You will calculate the S array, which is the size of the subtree. So you will go from down to up like this, bottom up DFS. So what will be S of 4? This much part. S of 4 will be 1. Because in this much part, this branch, only one node is there. S of 5 is also 1. S of 6 is 1. S of 7 is 1. What will be S of 2? The number of nodes which are coming under this blanket. Number of nodes coming below node number 2, including node number 2. So S of 2 is 3. There are 3 nodes under this shelf. S of 3 is also 3. And S of 1, the whole tree where node number 1 is the root. So S of 1 is 7. So like this you can calculate, right? And you will know what to do. So let's assume you have calculated the S arrays already, okay? Now it is very easy to calculate the branch sizes. Let's say this is node 1. This is your node V. you have done the bottom of DFS DP, okay? This is node 1, 2, 3. This is, let's say, arbitrary number V. This is C1, this is C2. You know the value of the sizes, okay? So for V, the first branch is what? This one. This one is nothing but the size of this is S of C1, which you have pre-calculated. The second branch is this one, S of C2. So in the B array which I am calculating, the first branch count will be S of C1. Second branch count will be S of C2. Now what about the parent? Parent is this part, na? Upper part, upper branch. Upper branch is nothing but total minus white part. Total, how many nodes are there in the tree? N nodes are there in the tree. Subtract the white part, which is what? S of V. The number of nodes coming under the node V. If you subtract that out, you will get the leftover upper part, which is 3. So N minus, the third value will be N minus S of V. So guys, you can calculate this thing for all the branches and you can make the special array. Once you get the special array, you can calculate the sum of product of all pairs. Do this thing for each node V and your job is done. The amortized time complexity will still be O of 1n and the type 1 paths have been calculated. Okay? Now, react with emojis if you have understood what is happening. And if you are my student, you must be knowing how the bottom of DFSDP code works. अब गाइस, सेशन बंद करने के पहले मेरा आपके लिए एक क्वेश्चन है. मैं कुछ नहीं बोलूंगा, मैं चाहता हूं मेरे बच्चे दिमाग लगा के इसका आंसर दे दे. अगर इसका आंसर दे दिया तो सेशन बंद होगा, नहीं तो सेशन बंद नहीं होगा. ओके? सो द Kumar K sir want to ask you this question. If I give you an array, one based indexing array A, how will you calculate A1 into A2 plus A1 into A3, like sum of product of all pairs an minus 1 into an? Do you know how to do this? Don't tell me the O of n square solution. वो जो मेरे बाजू वाले घर में जो 5 साल का बच्चा पैदा हुआ है उसको भी O of n square solution आता है, वो नहीं जानना मुझे. ठीक है? How can you calculate the sum of product of pairs efficiently? You don't need to know any extra formula. You can use common sense and do it. Okay? You know the sum looks like this, right? A1 multiplied by A2. See, A1 dot A2 plus A1 dot A3 plus A1 dot AN. So take A1 common, then what will it look like? A1 multiplied by A2 plus A3 plus AN. Similarly, the second number is multiplied with all third to nth numbers. Similarly, the third number is multiplied with A1 can be calculated in O of 1 time. You already know the value of A1. And the sum of the rest of the numbers can also be calculated in O of 1 time. This is what? This is nothing but total minus A1 now. Got it? A of 2 you already know. This is what? This is total minus A1 plus A2. Or A1 plus A2 you can have the prefix sum now, which will tell you the sum of the first two numbers. You can calculate each of this expression in O of 1 time and in O of n time you will be able to do. So now I'm opening the Google chat. I want you guys to use the lovely brain and tell me what are your logics to calculate the sum of product of all pairs in an array. थोड़ा बहुत लिखिए, अपने थॉट्स बताइए. तब तक मैं चैट जीपीटी से फोटो ले रहा हूँ. ठीक है? देखो, there are two methods. I will teach you everything. Okay? One is the square sum method. Okay? You can memorize this formula if you want. Like I really do. Today chat GPT, even gave me the wrong answer for the. Chat GPT was saying that 18 is a perfect square. When I was trying to prompt it about some hard coding question testing, ChatGPT was saying 18 is a perfect square, 72 is a perfect square. ऐसे ऐसे बोल रहा था, मैंने स्क्रीनशॉट सेव रखा है ChatGPT का. Today only it was saying 18 is a perfect square. So do it like that and solve the problem like that. इतना गुस्सा आया मुझे. 18 perfect square होता है. पता नहीं इतना ये लोग पैसा खर्चा डाल के क्या मॉडल बना रहे हैं, मुझे नहीं समझ आ रहा है. Anyways, going below, guys, this is one way, and the second way is this one. Like I'm just taking the images. मैंने ChatGPT को पहले से बोल के रखा था कि ये सब बना देना. Okay, so this will be pic 2. I will upload both the pics. Okay. अरे नहीं भाई. Okay, you guys understand everything, right? Very intelligent you are, right? And guys, I hope you know where is the bottom of DFS DP code. Like I will just go to my Notion document to show you. Like, if I was in a contest, what I would do? मैं जल्दी से अपना Notion document खोलता, फिर मैं ऐसे नीचे जाऊंगा. अरे ट्री का है किधर भाई? You go to tree course. खुल जा सिम. ये देखो मेरा कोड यहाँ पर पड़ा हुआ है. मैं सीधा इसको कॉपी करूंगा. सी DFS is happening and here I am iterating all the child subtrees. तो मैं तो एक एक चाइल्ड सब ट्री का सब साइज वाइज देख के स्पेशल एरे बना लूंगा. I will iterate the special array one more time. Iterating special array is not a big deal. It is just iterating all the adjacent nodes of the current node. So each node you are visiting only 2 to 3 times at max. Okay. So 2 and 3 and time complexity and done. The problem has been solved. For type 1 paths, in Babaji ka number baki hai. You have to calculate type 2 paths, add them, and then you can solve the problem in Codeforces. Hello guys, with the name of God Ram Ram. Jokes apart, this is the part 2 of the session. So, you know what? We discussed that we have to calculate the singular paths where UVW is on a single line. Everything feels so good when UVW is on a single line. But guys, you need to cross question this. None of you cross questioned it. And that's why we will invoke our deep thinking in this session in this particular way. So what I'm going to basically do for you is that we are assuming that if a tree is very big, we are only considering this much part of the tree, right? U, then this, then a node V, then this, then a node W, right? So let's say this is A1, this is A2, this is A3, this is A4. You know that product of numbers from U to V multiplied by product of numbers from V to W multiplied by product of numbers from U to W. This is a perfect square if and only if this is a perfect square if the value at node V is also a perfect square. Okay. So you know that, right? Because U to E like this, V to W, I'm showing you the paths of the lines, and U to W. See, all nodes are coming 2 times in the product, so they are a perfect square. Only this guy, this V guy is coming 3 times over all the paths. So it is looking like A of V the whole cube, which is A of V the whole square multiplied by A of V. So this thing can be a square only if A of V is also a square. Square multiplied by square will be a square. So that's why A of V needs to be a square. But guys, you never questioned one thing. What? Let's say UVW was equivalent. Like, I am sure no one on any in any DSA course or training or any YouTube video, apart from me, is going to cover this thing. UVW is 258. Let's say your algorithm is able to calculate it properly when V is equal to 5. When V is equal to 5, let's say your algorithm is able to calculate it properly. Like you were traveling each node, your V was 5, and you were able to find a valid U and you were able to find a valid W. Now the question should be in your mind should be, sir, how can we be sure? Are we avoiding overcounting or not? Are you sure you are not doing any type of overcounting? Are you 101% sure about it? Why overcounting can happen? If this is 258, what if in your algorithm you were at W and this W would be your V? Would this not create any type of problems? I'm saying, what if your actual path was looking like this? First there was U, then there was W, and then there was V. Now what would be the product looking like? Now this is my V. So U to V, one path, W to V, second path, and U to V, 3 paths. So now the answer totally depends upon whether A of W is a perfect square or not. So no overcounting will not happen. Why? Because if this is your current V, you will try to find U in this branch. You will try to find W in some other branch. You will never find U. You will never try to find, U and W in the same branch. So repetition will never happen. One more thing, because we are dealing with unordered triplets, now 258 is counted same as 582 or any permutation of 258 has 6 permutations. We are counting all those 6 permutations as one only. So the biggest observation is no matter in which order UVW are written. मेरे कहने का क्या मतलब है? Let's say this is X, this is Y, and this is Z. Now no matter who is X or who is Y or who is Z, if you want this singular path from start node to end node to be valid, the middle node which you have selected, it should be a perfect square. So if it is like X, Y, Z, then A of Y should be a perfect square. Instead, if you wanted the singular path from X to Y to be a perfect square, then the middle node Z needs to be a perfect square. So these labels don't matter. You are just trying to count the simple paths which are valid. If a simple path is valid, then you can be rest assured that the start node of that simple path you have considered The end node of that simple path you have considered, and the middle node was a perfect square, you have considered that as well. Because what are we doing in our algorithm? If we try to check our code, which whatever I taught previously, I taught something, right? Previously, something important. I was teaching that, let's say this is our tree, okay? And this is my node V. So if I try to isolate my node V, if I try to isolate my node V, it will look like this. This is my node V, and this branch has 3 nodes. This branch has 3 nodes. I can calculate how many nodes are there in a branch by using bottom up DFSDP and doing like bottom up DFSDP going from bottom to up, and then calculating the number of nodes in each subtree. If you don't know how to do these things, please do my prerequisite course, which is completely free. Click on this link and do it now. Another branch is upward branch. This also you can calculate. There are how many nodes in the upwards branch? 2 nodes. So you only use your brain and think that U and W can be put at which places? U can come here, W can come here. So how many ways are there? If this is U, this can be W. For U, there are 2 options. For W, there are 3 options. So 2 into 3, 6. 6 paths are possible. 6 singular paths are possible from this UVW or this UVW or this UVW or this UVW, or you got the point, right? 6 paths are possible if you consider your U is coming from here, W is coming from here. But if U is coming from here and W is coming from here, then 2 into 3, 6. See this also, na? That's why we make an array of all the branches like this. 2, 3, 3. And now we will try to find sum of product of all the pairs, which is 2 into 3 plus 2 into 3 plus 3 into 3. It can happen now that U is from this branch, V is from this branch, then sorry, U is from this branch and W is from this branch. Then UVW like that. That is also singular path only. A simple path is nothing but a path which starts at one node and ends at one node. And in all those paths, V was acting as the central node. So you will never do a overcounting. Why? Because when you consider any other node as V, na, I agree you count simple paths. But in all those simple paths, this node V will be considered as the middle node. Got the point? If, let's say, for this V, this U and this W was valid. The biggest confusion you might have, let's say this UVW was valid. Then you might think, sir, what will happen when my V comes here? Will it not think that this V, this W and this U is again valid? No. Why? Because if this is your V, then there are only 3 branches. This branch, and this branch. You can never select U and W from the same branch. We are always making sure that our U and Ws are from 2 different branches. That's why the overcounting does not happen. And no one explained it deeply to their students. तो बच्चे लोग क्या होता है, बस सर बोलता हाँ बोल के चले जाते हैं, पर उनको समझ में नहीं आता ऐसा क्यों हो रहा है. मैंने तुमको बता दिया कि ऐसा क्यों हो रहा है. तुम जब जब डिस्टिंक्ट वी लोगे तो वी हमेशा वो पाथ को गिनेगा जिसमें वी उस पाथ के बीच में आ रहा था, और कभी भी ओवर काउंटिंग नहीं होगी. ये यू है, ये वी है, ये डब्ल्यू है, समझो गिन लिया तुमने पाथ. अब जब तुम डब्ल्यू वाले नोड पे आके इसको वी समझोगे तो कभी भी ये यू और डब्ल्यू समझ ही नहीं पाओगे इस चीज को, क्योंकि ये दोनों यू डब्ल्यू एक ही ब्रांच में आ रहे हैं और एक ब्रांच में 2 नोड उठाना अलाउड नहीं है. So guys, react with emojis if you have understood the deep essence that why no overcounting can ever happen in type 1 paths. Has that concept gone deep in your brain? Can we now go ahead? Okay, now let's talk about type 2 paths, which is again very, very important. We call them as T-shaped paths. These are very important types of paths. Okay. Type 1 paths we have calculated. Type 2 paths is such a lovely thing. It requires such high level of such higher level of thinking it requires. I was just astonished when I saw this. T-shaped paths. Can you even imagine? T-shaped paths. कहने का क्या मतलब है? So, yeah, like I was just 1 minute before starting the session, I wrote the code and submitted it on Codeforces. Okay. Anyways, what are T-shaped paths? It is given in the Codeforces example also. This is called as a T-shaped path. It can happen to anyone, so never laugh about it. Okay. Where U is here, V is here, W is here. Now the problem is that, you know what? You go from U to V like this, V to W like this. Consider the path U to V, multiply all the nodes, V to W. Then consider all the nodes from U to W. When will this path be a perfect square? And this will give you a revelation to such a fact that that you will feel astonished. ये जो पूरा डायग्राम है, अगर इसमें मैं तीनों पाथ को कंसीडर करके प्रोडक्ट करूं, तो when will it be a perfect square? Check which node is coming 3 times. All the nodes are coming 2 times except one node. All the nodes in the product are coming 2 times except one node. अगर मैं गूगल चैट ओपन करूं, क्या किसी के अंदर इतना दिमाग ऑब्जर्वेशन है वो मुझे बता पाए कौन सा नोड 3 बार आ रहा है प्रोडक्ट में? उसी को तो पकड़ना है. Which node is coming for 3 times in the product? कोई है जो लिख सकता है? The क्या बोलते हैं, द नोड एट द इंटरसेक्शन ऑफ द टी शेप्ड पाथ. दिस इज द टी शेप्ड पाथ, राइट? और अ वाई शेप्ड पाथ. देखो ऐसा है, ध्यान से देखो. द पाथ इज लुकिंग लाइक दिस. दिस इज यू, दिस इज वी, दिस इज डब्ल्यू. इनके इंटरसेक्शन में जो नोड आ रहा है, लेट्स कॉल इट नोड एक्स. वी हैव डन दिस टाइप ऑफ कॉन्सेप्ट इन ग्राफ कोर्स आल्सो व्हेन आई वाज टीचिंग स्विगी एंड गूगल OAN interview problems. So guys, let's call this as node x. This random node x, the fate of this path depends on this random node x. If a of x is a perfect square, 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 then this path, t-shaped path, will be also a perfect square. Now the problem is that these are the type 2 paths. The type 2 paths are the paths where u, v, w are giving rise to a t shape. So u, v, w is looking like this. There is somewhere u, and then there is somewhere v, and then there is somewhere w. Okay? Somewhere there is u, somewhere there is v, and somewhere there is w. Okay? At their T junction, there is a node which is X. If that node is a perfect square, then you got the point, right? Now we don't need to take LCA. Now the solution which comes out will be very, very brilliant. Okay? So listen to me carefully and just chillax. This is U, this is V, and this is W. At their intersection, there is X. Question is asking us to calculate the number of valid triplets UVW, right? Question हमको क्या बोल रहा है? Calculate the valid triplets UVW. Forget about type 1. Question is saying for type 1 we are done. भूल जाओ उसको. Question is saying calculate the valid UVW paths which are T-shaped in nature or Y-shaped in nature. यार जो बोलना है बोलो. Everyone react with emojis if you understand. This is what the question is asking. That count the number of UVWs which are T-shaped such that their intersection point is a perfect square. देख रहे हो कितना हार्ड है. जिन्होंने कॉन्टेस्ट में चीटिंग किया उनकी बात नहीं कर रहा हूं. जैसे कि अगर मैं दिखाऊंगा इस क्वेश्चन के कितने सबमिशन है, 2700 सबमिशन है. अगर वो 2700 लोगों को रूम में लॉक कर दिया जाता और अगर उनका इंटरनेट और एआई मॉडल कट कर दिया जाता तो 2700 में से सिर्फ 2070 ही सबमिशन आते एसी वाले. सच सच बता रहा हूं, 90% लोगों के अंदर दम ही नहीं है कि इसका कोड या लॉजिक भी लिख पाए. जाके आप पूछ लेना, जिसने कोड लिखा वो समझा भी नहीं पाएगा उसने क्या किया. तो रियल में क्वेश्चन सच्ची में हार्ड है, इसका रिस्पेक्ट करो. सबने छाप के किया वो अलग बात है, बट रियल में कितना मुश्किल है ये इंसानी ब्रेन के लिए. अब हमको पता ही नहीं चल रहा है हाउ डू वी काउंट यूवीडब्ल्यू विदाउट चीटिंग सच दैट इट इज अ परफेक्ट स्क्वायर. एंड द परफेक्ट स्क्वायर कब होता है? व्हेन द इंटरसेक्शन नोड इज अ परफेक्ट स्क्वायर. सो गाइस द सॉल्यूशन इज वेरी सिंपल. यू जस्ट हैव टू चेंज योर वे ऑफ ऑब्जर्वेशन. थोड़ी देर के लिए मुझे भी नहीं आ रहा था तो फिर मैंने भी यही किया. You just change your way of observation. Rather than counting UVW, Kumar Kesar started calculating all the valid quadruplets UVWX. हम UVW को नहीं गिनेंगे, हम ऐसे quadruplets गिनेंगे, 4 पैर वाले UVWX such that X is the central node. X is a perfect square because X का ट्रैक कैसे रखेंगे? अगर UVW का ट्रैक रखोगे तो X का ट्रैक ही रख ही नहीं पाओगे. पता ही नहीं चलेगा भाई इनके इंटरसेक्शन पे कौन आ रहा है, कौन है परफेक्ट स्क्वायर. उम्र बीत जाएगी, एक्स नहीं मिलेगा. तो एक्स को मैंने अपने काउंटिंग में ला दिया. सो रेदर देन काउंटिंग यूवीडब्ल्यू वी विल काउंट द क्वाड्रप्लेट्स यूवीडब्ल्यूएक्स सच दैट एक्स इज द सेंट्रल नोड, एक्स इज अ परफेक्ट स्क्वायर, एंड देन देयर आर 3 ब्रांचेस गोइंग आउट. 1 ब्रांच हियर, 2nd ब्रांच हियर, 3rd ब्रांच हियर. Multiplication, if there are 5 nodes here, 5 nodes here, 5 nodes here, answer is 5 into 5 into 5. Always. Right, brilliant, brilliant, brilliant in the Google chat. If you understand how brilliant is this, if you include X also in your counting and start counting like this indirectly counts all the valid triplets UVW also. Counting UVWX indirectly calculates all the valid UVW such that they are type 2 paths. Okay, so it is very deep things are going on here. So इसको देखने के लिए आंखों का और ऑब्जर्वेशन का जरूरत है. So guys, the trick is instead count valid quadruplets. Count valid quadruplets UVWX such that X is the center of intersection of the other three nodes U, V, W. This makes sure we calculate all the distinct triplets U, V, W. So guys, instead we will be counting valid quadruplets UVWX such that X is the center of intersection of the other three nodes UVW, and this will also make sure that we calculate only the distinct UVW. फिर से repeat नहीं होगा for a particular X. Okay? कभी भी UVW distinct triplets which are T-shaped, कभी भी repeat नहीं होगा UVW. क्यों? Common sense ना. If this is U and this is V and you are sure that they are making T-shape, तो उनका point of intersection will be distinct. That's why we are calling point of intersection as X, and we are counting these triplets for each and every X from 1 to N. It means all our UVWs will also be distinct. So much brilliance in one question. So guys, what is the solution now? First, you will calculate type 1 paths, and for type 2 paths, what will you do? Like this is the tree given to you, like this. Now you guys have to tell me what will you do, okay? I will not say anything. This is your node X. What will you do? Very simple. Check all the branches. First branch, second branch, third branch, fourth branch. Guys, for the given node X, if I try to create a branch array, can anyone tell me how the branch array will look like? If I'm considering this as the node X, I'm considering node X and I know that A of X is a perfect square. I can check whether A of X is a perfect square or not. How to do that? Don't ask me. बहुत उम्र 20 साल के ऊपर हो गई है, नंबर परफेक्ट स्क्वायर है कि नहीं कैसे चेक करने का मैं तुम पे छोड़ दिया. अब if the node X is a perfect square, then there are 4 branches from where you can pick up UVW. All their intersection will be X only because they are the branches. So guys, I'm opening the Google chat. Tell me the size of all the branches. 2, 3, 3. Okay, I will stay silent. तुम लोग को अपना दिमाग यूज करना है और गूगल चैट में मुझे बताना है कि हर ब्रांच का साइज क्या है. 2, 3, 3, 2. घनत तुमने फिर से कोई बात नहीं, गलत आंसर लिखा है, सही आंसर लिखो दूसरों के ऐसा. 2, 3, 3, 2. So 2, 3, 3, 2. 2, 3, 3, 2. Okay, listen to me carefully. So now what will you do? U you can take from here, V you can take from here, W you can take from here. So guys, what will be the answer? Sum of all the triplets. Sum of the product of triplets. So it will be, if this is A1, A2, A3, A4, what will be the answer? A1 into A2 into A3 plus A1 into A2 into A4 plus A1 into A3 into A4 plus A2 into A3 into A4. So guys, you calculate the branch array and then calculate for the branch array for given node X, calculate what? Sum of product of all triplets. So that's it guys, okay? But now the problem is how to do it efficiently. You guys know the O of n cube algorithm to calculate this, right? Guys, react with emojis if you really know the n cube algorithm. If I give you any array, can you calculate summation of ai, aj, ak such that I less than j less than k? You can run 3 nested for loops, na? One for loop, second for loop, third for loop, and then sum equal to sum plus ai into aj into ak. If I create a branch array for a given node, okay? But you don't need to worry the amortized time complexity. Like, okay, you are doing it in O of n cube currently, but this is not a good thing. You can calculate the sum of product of all the triplets in O of n time. This is the formula. That's why I was showing it to you earlier. Like, this is a very standard formula, but you might not remember. तो ये बात को याद रखना. लो, इसे कोड की भी जरूरत नहीं है आप लोग को, तो आप बहुत स्मार्ट हो. क्या है फॉर्मूला? This is the formula, guys. PK. So, guys, see, okay, AI, like you just take the sum of all the numbers in the array, their cube, minus sum of all numbers in array multiplied by sum of squares of all numbers in the array plus 2 times sum of cubes of all numbers in the array divided by 6. देख रहे हो कितना भयंकर चीज है? So this can be calculated in O of n time. Why? Because sum of all numbers in the array O of n में हो जाएगा. Sum of square of all numbers in the array O of n में हो जाएगा. Sum of cubes of all numbers in the array O of n में हो जाएगा. In this document you will find, ये जो मैं डॉक्यूमेंट आपको दे रहा हूं उसमें आपको मिलेगा, ये जो डॉक्यूमेंट है इसमें आपको इसका फॉर्मूला मिलेगा. तो गाइस हो गया ना, रिएक्ट विद इमोजीज हो गया आपका काम. ब्रांच एरे O of n में बना था, तो O of n में you can calculate this thing for each node x. So guys, now the problem looks so brilliant, right? What do you have to do? Let's say this is my node V. Then what will I do? I will calculate its branch array and I have to iterate all the u's and w's. So what will I do? Sum of product of all pairs. And if this was my node x, then same thing, the branch array, but sum of product of all triplets. Same branch arrays you can calculate and you can apply the pairs formula and the triplets formula for each of them. Add all the counts to your sum and the job is done. Clear? Now I'm showing you the code also. So yeah, this is my code. Direct link. Code link. Okay. So it is a very nice problem. Okay. There is a Zomato way problem very similar to this. Okay. Which I taught few days back only, by the way. So guys, see what is happening. See. Answer 1, answer 2. Took the input of the tree, then doing bottom up DFS DP. See, bottom up DFS DP. Okay. Calculating the branch array B. Push all the child subtrees and ऊपर अपने अलावा कौन है, total number of nodes minus our subtree. If the current node is a perfect square, I have pre-computed all the perfect square in the CK array. If the current node is a perfect square, answer 1 equal to answer 1 plus sum of product of all pairs in array B plus जो करंट नोड V है उस वही, तो जब दूसरी बार इटरेशन करूंगा उसको x अज्यूम करूंगा ना, तो उसी को उधर के उधर x लेके वो दूसरे वाले टाइप 2 पाथ भी गिन लो. आंसर 2 इक्वल टू आंसर 2 प्लस sum of product of all triplets B, and guys the problem is done. Okay, so everyone react with emojis if these things are going deeply in your brain. Nice concept for you. You are becoming strong. You can do this in an interview also now. Okay, you can apply the same things on binary tree and PST also. Never forget. I have full faith in you. Make sure you do the right things in your life.